Thank you, Eleanor. It's great to be here at CogX, and thank you for the introduction. I am honored to be hosting or moderating this session with two amazing speakers, Sir David Spiegelhalter and Ben Page, and I'll just do a quick intro of both our speakers, and then I'm going to hand over to David, who's going to kick us off with a whirl around statistics. So David Spiegelhalter, many of you know, he's the chair of the Winton Center of Risk and Evidence Communication in the Statistical Laboratory at the University of Cambridge, and one of the most cited and influential researchers in his field. Elected president of the Royal Statistical Society in 2017 and author of the best-selling book, The Art of Statistics, Learning from Data. And we also have with us today Ben Page, who is the CEO of Ipsos MORI, has been there actually since 1987 and spent his whole career directing thousands of surveys and pollings around the world, and is named 100 most influential people in the public sector by The Guardian, and has won multiple awards and sits on the advisory board of IPPR and a trustee of the Center of Aging Better. But I want to kick off today's session on data and the importance of it and the role of statistics by asking David first. As we all know, the Prime Minister has paid special attention to statistics now more than ever. And you point out in your book that when done right and asking the right questions and understanding the limitations of data and statistics, they do, when understood well, they do offer essential tools for policy, but also solving crimes and catching faults in hospitals, etc. But I was wondering if you could kick us off today by giving sort of your view of the world through the lens of statistics. Thank you, David.
Yeah, thanks very much. This is a wonderful opportunity for me to plug my book, of course, which I'll be ruthlessly doing, but also to make the link between the importance of statistics, understanding their strengths and limitations, and the current epidemic. And that's what I'd like to talk about briefly. Okay, can I have the first slide, please? Put this up. So, oh, that's me. Next slide, please. Next slide. Oh, yeah, that's the book. Plug, plug, plug. Next slide, please. Okay, so I start the book by making this really important point that data does not speak for itself. Could you click again? Sorry, I'm not controlling these. Yeah, so I use a quote from Nate Silver, which I think is so appropriate to the current era, that, saying no, numbers do not speak for themselves. We imbue them with meaning. We speak for them, and nothing could be more true at the moment with the number of numbers being passed around COVID, which desperately need interpretation. You cannot just look at the number and know what it means. Next slide, please. Okay, so the point is that stats education, which I'm deeply concerned about, is changing. And if this was a live audience, I'd be asking how many people have had stats courses and how many people actually enjoyed them, and all the hands would come down. Because, the way I learnt stats, actually the way I've taught it, is, lots of formulas and tests and probability theory and sampling distributions of the sampling mean and things like that, of the sample mean and so on. But it's changing, and my book reflects that. Probability theory is left very late in the book. The crucial thing is to focus on problem solving, the data cycle. How can the data we've got a problem, and then we look whether the data can help us. We don't start with the data, essentially. We start with a problem. Okay, so can I have the next slide, please? This is New Zealand is the World Centre for Stats Education for reasons which I won't go into. But I adapt this idea in the book strongly about what's called the PPDAC cycle, where you start with a problem. This is something from the New Zealand school system. What do we want to know? We want to know about what the impact of the COVID epidemic is. We've got a plan. Okay, that means going out and trying to find information, measuring what we can. But we got to design it. We got to choose what to do. Do we do a random survey of people to find out how many are infected or whatever? We get some data. We have to wrangle it, clean it up, and do things like that, and we analyze it. But analysis, again, a lot of that is just informal data visualization, choosing the right metric, choosing the right statistic to look at and compare visually. And then the tiny bit of this whole cycle is when we actually do some what you might call formal statistical analysis, all the regressions and theta, all that sort of stuff. But it's a tiny bit. because then we get to the conclusions, the communication, and then we start again around the circle. I'd just like to illustrate those ideas with the COVID epidemic. Next slide, please. So every week we get diagrams like this from the Office for National Statistics, excellent statistics showing, for example, this is just total deaths in the country, the blue line, and red deaths, which are deaths with COVID on the death certificate, the red line, and with some jumps because of that little bumpy bit at the end for the blue line is purely an artifact of the fact that there was VE Day and the registration offices were closed. So we have to understand immediately how the data is collected. I've seen people trying to interpret that bump. It's complete nonsense. Okay, next picture. Then we have to maybe construct some indices about excess deaths, which the ONS do. But that is not something we measure or count. We have to construct it. They've chosen the 5-year average, which I think is reasonable. But there's all sorts of other measures we could use as the basis. We could use what we might have predicted to have happened in the country had the epidemic not come along. And that would give us a very different figure. So there we see excess deaths. The blue are the COVID. The green are non-COVID excess deaths. So immediately we've got a mystery. We've got a problem to solve. What's happening? Why is there a big burst in non-COVID excess deaths? Okay, next slide, please. So then we can start dividing it up by the place of death. So the next part of the cycle, the next part of the detective story, we can look at what's happening in care homes, the top left, and the homes, hospitals, and in other places. I'll just quickly go through this, that the hospitals show a huge burst in COVID deaths, but a big reduction in non-COVID deaths. They're exporting their deaths. They're closed. Well, they're not quite closed, but A&E attendances have halved. They're not doing routine admissions. The hospital admissions are way down. What's happening in care homes? There's a big burst of COVID deaths, but about half are non-COVID deaths. Now, a lot of suggestion now that in fact many of these, the majority, I believe, are in fact COVID deaths, but not diagnosed because they haven't got the typical symptoms. But what's most interesting, what gets least publicity, is what's happening in the homes. You see, there's very few labeled as COVID deaths and a huge burst of non-COVID deaths, which I think many people would believe have been moved out of hospital. People have just not going to hospital and they're dying at home. Now, that's not such a bad thing, but how many of those people would have survived had they gone to hospital? A huge extra mystery story. Okay, next slide. I'll just quickly go through these. Then we look at excess deaths by numbers of deaths by age. And we see this massive burst of COVID deaths in older age groups for females on the left, males on the right. Huge burst. So then we think, well, actually that shows they're focused in older people. What about the young people? So let's look at that. Next slide, please. Let's look at that diagram, but for the young up to age 45. And the black line is what we'd expect to happen, 5-year average. And we see essentially there are some COVID deaths, but actually not that many extra. This is not, has a very little impact on under 45s. And in fact, we see, if you look at the right in the middle of the graph, a deficit, young men aged 20 to 24, but a 30% reduction in mortality during the lockdown. This is the one group that have benefited from the lockdown. So I think I'll stop there. I won't go on to the last slide because I'm taking enough time. So thank you very much. And so basically my story is that the importance of seeing, none of this has involved any complex analysis at all. It's just using the data to try to solve problems, and all it ever does is raise more questions and more problems. And so I'll stop there. Thank you.
How do you feel that, I mean, of course, statistics are such an integral part of how we use and understand data, and they're such the ground on which most of AI, of course, is built. Yep. When we talk about misunderstanding of numbers, how optimistic do you feel about public understanding of this ingredients of AI? I've got to pass over to Ben for public understanding stuff, although I'm interested in it. I don't actively study the public understanding of numbers. I suppose I try to improve it maybe by trying to improve the communication.
And all I'm going to say is I think this is a vital issue in the modern age, what I call data literacy. In the modern age of data, of machine learning and AI, the use of statistics, and this epidemic is revealing more than any lesson I could try to do about the importance of data literacy. And that means two components. There's a really skilled group of people who can go around that cycle, do the communication clearly, and understand the strength and the limitations of the data and can get up and communicate it. But at the same time, the absolute need for general education of the population to ask the right questions, to say, well, what am I not being told here? What do these numbers mean? Why is this the whole picture? Who can critique the numbers? And this is, nothing could be a better, as I said, lesson of the importance of this than what we're going through at the moment.
For the last 8 years, we've been measuring in annual surveys how right or wrong people are about a whole load of basic facts about their societies all over the world. And I think what it's highlighted is that people are wrong about all sorts of statistics. They're also bad, as David knows, at calculating things like risk and probabilities in their own lives. With COVID-19 at the moment, we have the vast majority of people in Britain very anxious about leaving lockdown. And one of the factors behind that, in a study we've just done with my colleagues at King's College, is that people overestimate by a factor of about 10 their chances of being hospitalized if they actually end up catching COVID-19. So I think the estimates I've seen are that 4% of people who catch COVID-19 end up in hospital. The public believes it's about 40%. And it's the same if you look at the proportion of immigrants in the population, the level of crime, almost, a whole range of areas. And I think one of the things that we find interesting is why people are wrong. And some of it is just statistical illiteracy, which is a huge problem. We've shown that I think around half of MPs can't even calculate correctly how likely you are to get heads twice in a row if you toss a coin. But most of us, many people in the population as a whole, would also have problems. But I think also what's the other challenge is that even when David's job is done, sadly, probably after David and I have left the planet and gone elsewhere, that humans are so subject to all sorts of other biases and confirmation bias heuristics and that we use in making judgments, that even if you have perfect statistics, which is a challenge in itself, people will be very driven by their own beliefs and their own internal biases in how they react to them. And I think that's another thing that we need to encourage people to contemplate. Why are you so wrong, as well as getting the statistics right in the first place?
Yeah, can I come in there? Because I really know that risk is two components. It's a bit like Kahneman's thinking fast and slow. You've got risk as understanding, thinking slowly, doing the numbers, and you've got risk as feeling, which we're all subject to. And you cannot, we'd love to sort of separate those. You cannot separate them. And so that's why I realized in my work that I have to understand a certain amount of storytelling, about narrative, about the fact of you are trying to, in a way, change people's feelings, which is, you can't do this. You can't just tell people what to feel, not to be anxious, not to be concerned. But I think it does mean you can at least try to get some feeling of proportionality between in a sense, the risk people face and their perception of it. So while fully acknowledging that this is an impossible ideal, and I don't even think I would want it to be, to be the case that everyone was these cold, rational human beings. What a ghastly thought. One can at least try to do that. And what I should say is I think this one is the biggest challenge to risk communication that there is, because of the massive gradient. The gradient in risk of getting it and then dying is to yourself is bigger than the normal gradients we experience in life. Age being totally dominant. That there's more than 10,000, I think up to almost 100,000 times the risk of a frail 90-year-old compared with a primary school kid of dying with COVID. 1 in 7 million school kids have died so far. 1 in 60 of the entire population of over 90s in this country have died from COVID so far. So, there's a staggering variation in risk that's almost beyond our human comprehension.
Can I just check? I think my line is a bit glitchy, but can you hear me now?
Yeah,
we can hear you. but we can carry on by ourselves.
I'm so sorry I lost you there for a moment. It seems that you don't need me at all, but that's I'd love to hear you just continue on. But Ben, I don't know if while I was offline whether you had a chance also to give your sort of whirl around the world and from your perspective. I mean, the perils of perception and the index of ignorance that I'm particularly fond of as one of your many publications. I wonder if you could just chat a bit about that and sort of how you feel that feeds into the way that what it says, but also how does it shape our behavior today in this current context?
So as well as looking at, how right or wrong people are about, say, teenage pregnancy levels around the world, or the level of immigration, or the level of unemployment, etc., or what might kill you, we've also, of course, we've done a sort of, it's a bit, I suppose you can argue about it, but what we've done is look at, on average, how right or wrong about some key facts about themselves are different countries. And I think one of the things that's interesting is that Italy, and the last time I saw this, that we'd done this a year or so ago, Italy and America were far more likely to be wrong about their own country than, for example, Germany and Sweden. So as on many other measures, there seems to be, where societies are more troubled, where societies are more divided, you're likely to get this, what appears to be higher levels of emotional innumeracy, where people overstate things that they're worried about, like unemployment in Italy, or indeed immigration in both North America and in Italy, than in countries that are slightly more at ease with themselves, like Germany and Sweden. So the Germans and the Swedes are reasonably sort of accurate about themselves. Americans, depending on who they are, whether they vote Republican or Democrat, and we can see this now in terms of COVID-19. If you're a Republican voter, you say there's no evidence that Black people are more likely to die from COVID-19. And if you're a Democrat voter, you say, of course they are. They're massively more likely to die from COVID-19. And so, again, it's interesting to see these national differences, but it seems to play back something about the divisions in those societies, that people seem to have such wildly differing and sometimes erroneous views about their own country. And of course, that makes it harder to govern those places if Italians, when they voted in 5-Star and Lega Nord a few years ago, believed that half their population was unemployed. Now, that's unimaginable. And it is high in Italy, but it's not half, anywhere near it. They believe that 30% of their population were immigrants. It's about 15%. So I think understanding that and just confronting that is helpful in understanding sort of some of the challenges that we face in getting across basic statistical facts.
Yeah, and I think that's why, communication methods, that's why I spend my time working with psychologists and web designers and testing materials to see what the impact of different means of communication is. I mean, for just very simply, we work with cancer patients, and in generally looking at risk for things like that, you can show, well, out of 100 people, this is how many people you'd expect to survive, and this is how many people you'd expect to die. And that's quite straightforward and very well tested and very well established. As I said, in this area where you have such an enormous range of orders of magnitude difference in risk to people, it's extremely challenging to do this. People have been trying to do this for a long time. You can make all sorts of analogies and stories, comparators, but it's still, and I really do think this is important because of, there was, while we're all under lockdown, in a way it was fine to induce a degree of fear and anxiety into the population, and we all obeyed amazingly well. Now, trying to tell essentially the under 45s that even if you get it, you're at very low risk is quite a challenge, I think. That really is difficult.
You're absolutely right, David. And I think we've even found that if we tell people, imagine you have a very bad, you've got a very bad disease and you need an operation, and 5 people who have this operation die, and the other half, we tell 95 people out of 100 who have this operation survive. Yeah. And then you look at how likely you are to have the operation. Of course, we get massively more people who are told about the 95 rather than the 5 choose to have it. So I think the government has a real job on its hands in conveying these statistics, particularly with the difference. I think the difficulty to me is that the public doesn't like uncertainty. So it doesn't mind drink driving particularly or speeding because it feels in control. But when you have to rely on an expert, whether it's you or me or the chief medical officer, saying that only 1 in 7 million kids has died, and that's much less than die just going to school every week, people just really don't like it, any risk in some way.
Yeah, and I think this is a problem, and that's why I but use the analogy, for example, that in the flu season 2014 or whatever, where kids are the super spreaders, which they're not, particularly for this disease. You had 16 school kids died, and I don't think there were any calls there to close schools or to stop the education system. So it's so that the kids there were both not being harmed more and causing more spread of the disease in the population. So I do think that these analogies and stories are useful. I also think I just put them out, but I think actually it's very worthwhile testing those. To see what the impact on people's feelings are. And I don't want to say people are wrong or anything like that, but as you said, when there is an actual active misperception, and that one should try to preempt misunderstandings and correct those in the most powerful ways one can.
Absolutely, I think you have to call it. I mean, frankly, I've come round to believing that you must, whenever you see something that is factually incorrect, particularly on social media, you have to call it out. Because, I get it every time I publish some opinion poll results. If they go one way, the Corbynites are all up in arms. If you go the other way, and you just have to say these are these are the numbers. But it's amazing how people are attacked.
Yeah.
Central London is not great on Wi-Fi. I'm just sorry about the glitch, but I lost you, Ben. For a second then, and you were talking about the US and Italy and the sort of perception gap between sort of the reality and sort of people's fears but I was just wondering if you could bring that back to the UK, and I don't know if you went back to the UK, but if you could talk about
Britain is overall, on average in Britain, we are about average in terms of how wrong we are about things on a whole range, which is quite interesting. We're not at an extreme on a lot of measures. We're quite mid-table. But it gets a bit difficult. But I mean, basically, if you're a Leave voter, if you choose our previous disagreement around Brexit, what's interesting in terms of trusted sources of information, both Leave and Remain voters or people of that disposition are about equally or trusting or not trusting of different media sources. But the one big difference, and this one's for David, is that Leave voters really don't like academics. And I don't know if this is because academics were seen as sort of being more likely to be left wing or more likely to be Remain supportive.
I think, well,
it's quite marked, and so
I know. I mean, because academics the majority probably were Remain. But I think my belief is that in terms of trust the trust in science and trust in it's doing very well at the moment, and it's something I strongly believe in, and that's actually why I kind of wish that they could separate out of the briefings and things like that, the sort of more political statements from the scientific statements. It's nice having them. I thought it was great at the beginning they were all up together, but now I really wish that there was a platform for the scientists and the statisticians to deliver some of this really quite subtle material themselves, and that's not so it's definitely seen as not taking sides of one way or another. I feel that the statisticians and other scientists come from a very reputable profession on the whole, who don't have strong agendas, and therefore should be able to present the information themselves.
A question for you, David, that I know you get asked a lot about comparing the UK, especially in the COVID crisis, to countries around the world. So China, I know you've been asked about Iran, Germany, all kinds of. But you could just talk about, people want to have those comparisons, but actually from a statistical perspective, how difficult that is to do.
I could go on for ages about the naive comparisons between countries is very difficult. Obviously, Britain's done very badly, you can say that, but trying to make comparisons, you should be doing it per million, and we're not sure about the data from other countries all the time. You can't just count the deaths labeled as COVID. You have to look at excess deaths and so on. Other people's are a lot delayed in terms of their reporting. And even that wouldn't be so bad if people then didn't immediately jump to saying, oh, that's because of X, Y, and Z, and immediately draw some strong conclusion from this comparison, because that's what people really want to do. They want to blame somebody and draw a conclusion. And that is so, I think, inappropriate.
I think, very unfortunately, we've run out of time. But and I do, you are absolutely epic heroes for dealing with all of that tech glitches. It must have been very stressful. So thank you very much for and having a fantastic conversation on the back of it. That was really brilliant.
We could go on for hours.
So for hello audience. Ben and David and Alexandra are going to jump into a Meet the Speaker Q&A session. So if you have a ticket that enables access to that session, please do join them there, and you can hear a few more of their amazing insights. And hopefully, Alexandra, you'll get to ask a few more of your brilliant questions. But if we were in the real world, I would ask everyone to give you an enormous round of applause. But I think we're also just going to have to say, you must pick up David's book, The Art of Statistics. It is brilliant. And it's a great gift, of course, to anyone struggling to understand statistics. Thank you so much, all of you, for joining us.
Want access to more CogX videos? Subscribe now for free at cogx.co.